to talk about building ontologies, or how we can apply building ontologies in making an ecosystem for building digital twin, for example. So what is the current situation in construction? Well, what you see is that there are erupting many tools out of the surface. More and more tools arise to do all of different kind of services. I listed here some of the services that we use, or the applications that we use within the Sphere project. So only within one project, European project about digital twins, we apply already that many tools. So imagine if you have like a large scale project, how many tools you use, or if you are managing many projects, the complexity is really large. And what you see, of course, is if you want to have a good cohesion between those tools, you also need good integration or easy data exchange. And so that is really like a challenge, because it's what I call the interoperability dilemma. Because if people start working together, the first time they say, okay, just drop me a file, and we'll figure it out how to import it into my system and do something with it. But of course, that is not scalable, not at all. And then after a while, people are starting to discuss, like, maybe we need some definitions. So if we have common definitions, we know what we are talking about. It might be easier. And at a certain level, we get like industry standards, and we all know those. You can have, for example, like classification systems like Uniclass, or we also have like IFC, etc. But exchanging that information doesn't say anything. An application doesn't know where is that information coming from, what is the meaning of that information, what was the context that information was being generated. So it's still difficult for a computer to understand. It needs a lot of interpretation. And in that sense, for example, IFC has also implemented model view definitions, where you can already create a little bit more of context to your information, so that it helps for the one who receives the data, that they know what is it about. But more and more, of course, the semantic web came to life, let's say. And also what we see is that the semantics, of course, is the right way to create context to data. Because if you just have data and you don't know what it means, it's difficult to do something with it. So that semantic, we can really like add that context on one hand, but on the other hand, we can also automate it, because if we know what the data means, we can also automatically do the interpretation by the machine. And of course, the more you automate it and the more you add that semantics to that data, the less ambiguity you have, and the more clear data is. And that is really important. If you want to go to an ecosystem where we can exchange data, there shouldn't be ambiguity about the meaning of the data. If we succeed in that, then we also would be able to succeed in creating an IT landscape that is where the data is open, and that you also have really like a grip on the data, and that you can create also robust and scalable integrations. And that's of course something we need to do step by step. We cannot do it in one time, but also here there's a grow model, and we want to go to that open integration model. That's also the idea that we have at Sphere. That it's not the idea to have to invent the golden platform where we can manage everything. No, it's rather like creating an ecosystem where building owners, where different stakeholders, communities, etc., they can create an IT landscape where they can manage the data they need for their purposes. So like also fit for purpose in an open integration landscape, that they also can switch tools, take better tools, newer rising tools, that they can fit it in a proper way. So ideally, you would say, okay, we want to build such an ecosystem within a certain domain, and then, for example, if you have really like a building, and you would define a certain language, a common language or ontology within the domain, and you could then start building tools based on that language, let's say, and then, of course, if everybody would do that, you would be rather easy, let's say, to create a scalable and interoperable ecosystem. But of course, it's not that simple, because if you just look at a building, it's not about one domain, but it's about many domains. It's about constructing it, it's about maintaining it, it's about the interaction with other systems, it's about system of systems, let's say. So it's not that easy to just talk about one domain. It goes about, yeah, you have to have the link for different domains. And on the other hand, also, there are already a lot of existing standards, already a lot of existing ontologies out there. I learned today there are 782 ontologies available on the web. So there's many information out there. So it's not just that we can start from scratch and do something. And in that sense, yeah, this is a little bit of an ecosystem. I just listed a few of those ontologies. There are many more. These are some well-known ontologies. Also, some ontologies we use within the SPEAK project. And on the other hand, you also have the different standardization bodies, also where Edward talked about from the SEN 442. But there are also different ISO standards available, and it's very complex to I will not go into detail because it's just it's a study on its own. It's I think a lot of people are working on that day by day. But how can we now apply such ontologies to exchange information between two applications? Well, what we did at Sphere, we said, okay, let's see what is out there and let's see what we can use for our purpose, having that building digital twin. So what we did was to list all those ontologies and look for what we need. And just as an example, I put here two ontologies, like for example, the bot ontology that we use to describe a building, just like the building, the zones, the rooms, and those kind of things, the building elements. And on the other hand, that we needed also something for sensoring and dynamic data, where we selected SSN and how you can link those two together. So this is a simplified image where we linked those two ontologies together and created a first small network of ontologies. This is something, of course, you can do and expand like the way you need it and also fit for purpose on your project and create that network of ontologies. Well, if you have now that network of ontologies, we have to check because we want to exchange information between two applications. What we see is that there is a big gap in between them, because how are you going to exchange the information between those two applications using those ontologies? Well, what we need to do is to have create a sort of interoperability layer and to make sure that, for me, the ontologies is just like a language, let's say, for example, like English. And what you want to do is to write a book with it. And you can write a book about many things. And what you need to do if you write a book, you create a certain context, a certain story within that language. The same is what you do with, for example, an ontology, bringing it down to an application where you have certain functionality that you want to support. So what we see in the industry is that you are going to create, for example, an OTL or object type library, where you can, based on the language, create already content like certain objects, like what is a kitchen, what do I need to know about the kitchen, what are the possible relations between a kitchen and other elements. That is something that is being defined within the ontology, but that you are going to make specific for the elements that you want to apply. So such an OTL doesn't need to be about the entire network, but can be about a part of the network. You can see that with the yellow bracket. And even an application, that application will even use maybe less data or requires less data to support the functionality it needs. And it's that part of the data that it requires that you want to put down in certain constraints or certain rules, so that you can define for your application, look, I want to have this information. For me, I don't need all the details of the wall, but I just need certain properties of the wall to perform my energy simulation. I only need certain properties of the window, and I only need certain relationships between those elements, not everything of the ontology, but just a part of the subset of data that you require for your simulation, for your process that you want to support with your tool. If you define that with certain rules and you can describe those rules in, for example, an open language like Shackle, then you can also define, okay, give me this information and
another application can give you that information and validate, making use of those rules, that all the information is available on one hand, and is complete, so that it's correct and that we can use it. That way we can
we define actually a framework how we can exchange information between those different applications. And it's a generic framework that you can reuse and reapply between different applications. So that is really the key message I wanted to bring today. I can see that my time is already done, but that's the key message I wanted to give.